Welcome to my YouTube channel, A Binary of Civil.
Today I am going to solve the third assignment of reinforced concrete road bridges. In this assignment, there are very lengthy problems he has given. Don't afraid of the problems by staring at them. These are all very simple problems. Okay, let's start. Following are details of RCC solid slab bridge. He has given clear span, center to center, effective span, overall depth, thickness of bearing cord, longitudinal reinforcement provided by 20 mm bars, and unit weight of concrete, unit weight of bearing cord, size of bearing, and size of vehicle load for bending and vehicle load for shear, and clear cover. So he is asking total dead load on slab. Obviously, dead load means self weight of concrete and bearing cord. Self weight of concrete is per unit area. What is the self weight? First of all, I will take dead load of slab. He has given much information in the problem, but we consider whatever is required. Clear? So now, dead load of slab is equal to overall depth into unit weight of concrete. Overall depth is equal to 1000 mm. Capital D is equal to 1000 mm. That is 1 meter. 1 into 25. This is 25 kilonewton per meter square. So this is per unit area, that is L and B are considering 1 and depth is 1. He has given that in the problem. And dead load of bearing cord. So bearing cord thickness into unit weight of bearing cord. Bearing cord thickness he has given it is, you can see here it is 80 mm. So you will substitute in meters. 80 divided by 1000 into 22. So you will get it is 1.76 kilonewton per meter square. So 25 plus 1.76 total dead load. 25 plus 1.76 26.76 kilonewton per meter square. So the answer is D for question number 1. Okay. So these are all lengthy problems. He has given much information in the problems. Don't be afraid of by staring at the problem. Clear? Very simple solutions. Now for question number 2. So same data he has given. He just changed overall depth. Sometimes he has given overall depth is 1000 or 900 and clear cover 50-40. So something like he has given. So but what he asked, we just take whatever he asked. So maximum bending moment. Maximum bending moment is equal to M is equal to WL effective square divided by 8. So here W maximum bending moment is due to dead load. So here total dead load is 26.76. So W is 26.76 and here it is 8. We need to calculate L effective. Okay. So L effective can be calculated by using total center to center span. He has given clear span is 10. So L effective can be taken as minimum of L1 and L2. So L1, I will calculate here L1 is equal to clear span plus overall depth minus clear cover 0.04 minus half of the diameter, that is 0.02 divided by 2. If you will calculate, you will get L1 is equal to 10.95 and L2 is equal to clear span he has given directly 10.5. Out of these two values, L effective can be taken as 10.5. Okay, minimum of L1 and L2. So it is 10.5 square divided by 8. You will get the correct answer is 368.78. But no answer is matched. Okay, so you can select answer D. It is approximately 340. So it is very closest Answer is 340. Okay. So answer D for question number 2. Next question. So I will not explain calculation of L1 and L2 again. Okay. So just follow this. Next, he has given more information and maximum shear force. Maximum shear force is equal to shear force due to dead load. So Q dead load into L effective divided by 2. So what is the total dead load? 26.76. This was calculated in the first problem itself. And L effective will become 10.5 divided by 2. So you will get it is 140.49 kilonewton meter per meter width. Okay. So here also no option is matching. So but the closest answer is 140. So almost 130. It is nearest option is option C for question number 3. Clear? Next question. So he has given same information. He is asking for maximum bending moment. Clear? Maximum bending moment we need to calculate. So first of all, from the information, I am calculating effective length again for one more time. So effective length is equal to L effective is equal to minimum of L1 and L2. So what is L1? It is clear span plus effective depth is 0.9 minus clear cover minus half of diameter. This is L1. So it will be 10.85 and L2 is, he has given center to center, it is 10.5. Out of this minimum is L effective is equal to 10.5. So this is the last time that I am calculating effective span. This is 10.5. Always in all the problems you will get 10.5 only. And effective length of vehicle we need to consider A suffix m is equal to 4.0 meters. And he has given for bending moment the vehicle load is vehicle load for moment Qm is equal to 21 kilonewton per meter square. Now we need to calculate maximum bending moment due to vehicle load. Maximum bending moment due to vehicle load is equal to MVL. Vehicle load is equal to 0.5 into Qm into AM L effective divided by 2 minus Qm AM by 2 into AM by 4. So just to substitute the values 0.5 into 21 into 4 into 10.5 divided by 2 minus 21 into 4 divided by 2, 4 by 4. You will get it is 178.5 kilonewton meter per meter width. Okay. So now in this problem you have not got the exact value. So maybe you need to consider so here the value is 178.5. So the option for this answer is directly as given option A, that is 178.5 is option. So answer A for question number 4. Okay. So now so you can see the problem is, the length of the problem is very high. So maybe it is completely one paper, but the answer is not even 1/4 of the paper. Clear? So just keep all the observations with you, whatever the required data. Consider only the required data. Do not consider much more data, whatever he has given in the problems. He has given in all the problems center distance, center to center distance, clear span, clear cover, diameter of the bars, and he has given some more. So in all the problems it is required to calculate effective length. So according to the given data in all the problems, so the effective length is minimum of L1 and L2. L1 can be calculated by taking summation of clear span plus total depth by neglecting clear cover and half of the diameter. Okay, so I will not explain this calculation of L1 again. So now you can go to next problem. So for this question, option A is the answer. So question number 5. So he has given maximum shear force. So maximum shear force, obviously L effective we calculated already, it is 10.5, and vehicle effective length of the vehicle, obviously it is AB is equal to 4.0 meter. So earlier it was taken A suffix M, that is for bending moment. Here it is for load, and QV it is load for shear. He has given it is 20 kilonewton per meter square, and maximum shear force is equal to QV into AV, L effective minus AV divided by 2 divided by L effective. You just substitute the values. This is the formulas. Okay, 20 into 4 into 10.5 minus 4 by 2 divided by 10.5. So you will get it is 64.76 kilonewton per meter width. Clear? So answer B for question number 5. Okay, next question. So as per working stress method followed in IRC, the balanced moment capacity. Okay, so same data he has given, and he has given M30 sigma CBC, Fu415 sigma ST. So as per working stress method, the problem is related to WSM. So balanced moment capacity. So we can see here it is. So sigma CBC, sigma ST 10, 190. We can calculate modular ratio M is equal to 280 by 3 sigma CBC. That is 280 divided by 3 into sigma CBC is 10, 9.33. And you need to calculate critical depth of neutral axis to effective depth. So that is M sigma CBC by M sigma CBC plus sigma ST. If you will substitute 9.33 into 10, 9.33 into 10 plus 190, you will get it is 0.329, and there is a factor J is equal to 1 minus K by D. Sorry, it is K by 3. This is K here. So that is 1 minus 0.329 divided by 3. It will become 0.89, approximately 0.9. Okay, this is J. And moment capacity or moment of resistance due to concrete is equal to MC is equal to half sigma CBC KJBD square. So half sigma CBC is 10, K is 0.329, J is equal to 0.89, B is equal to, I will take unit width, that is 1000 mm, D is equal to, here I will calculate D for you. So D is equal to effective depth, capital D minus clear cover minus dia by 2. That is capital D is 1000, clear cover is 50 minus 20 by 2. So I will get it is 940. So this is 940 square. You will get MC is equal to 1293.3 634, 1293.6 kilonewton meter. This is a maximum bending moment that a balancer section can resist. 1293. So answer is D for question number 6. Now question number 7. As per working stress method, the required area of tensile reinforcement due to applied moment. So now required area of tensile moment. So obviously we calculated M is equal to 9.33 in the earlier problem, and K is equal to X by D, that is XC by D, it is 0.329, and J is equal to 0.89. We have calculated all the things in the problem. Now AST required for tensile reinforcement will be M applied divided by sigma ST into JD. That is how much bending moment he has applied. It is 300 kilonewton. 300 into 10 power 6. Sigma ST is 190. J is equal to 0.89. D is equal to, so here D is equal to, overall depth is 900. Clear cover is 40 minus 10. It will be 850. It is not 940. So it is 850. So you will get it is 2087.2 mm square. So per meter width. So this is answer D for question number 7. Next question. As per limit state method, the lever arm factor J for balanced section is. This is problem of LSM. So first of all, we'll calculate small d is equal to capital D minus CC minus pi by 2. So you will get it is 1000 minus 50 minus 10, that is 20 by 2. You will get it is 940 mm. And XU limiting. So the limiting depth of neutral axis based upon the grade of steel for FE 250, FE 415, FE 500. This is XU lim or limiting depth of neutral axis is 0.53 D. XU lim is equal to 0.48 D. XU lim is equal to 0.46 D. Clear? So now for FE 415, the XU lim will be 0.48 D. That is 0.48 into D is equal to 940. It will be 451.2 mm. Clear? So now lever arm J is equal to Z by D. So that is equal to D minus 0.4x divided by D. So D is equal to D, it is how much? It is 940. minus 0.4 into 451.2 divided by 940. So it will become 0.808 is the answer. So option B for question number 8. Very important. These are all similar questions in this assignment, especially in reinforced concrete road bridges. There is no new variety of problems. Same questions will be asked in the exam. Okay, keep it in mind. If you will solve hardly 40 problems, the exam will be over. You will get the NPTEL certificate very easily in this course. Okay, repeated problems. And coming to question number 9. So he has asked the tensile reinforcement in the balanced section is computed as per limit state method. So obviously D, if you will calculate, you will get it is 940 mm. XU lim is equal to 0.48 into 940, already calculated, 451.2. Now for a balanced section, both compressive force and tensile force will get equated, right? So compressive force is equal to 0.8x B 0.445 FCK. So this is based on the stress block diagram. Is equal to tensile force is equal to 0.87 Fi AST. So you need to calculate here AST balanced is equal to 0.8x B 0.445 FCK divided by 0.87 Fi. So if you will calculate 0.8, 451.2 into B is 1000, 0.445 into FCK is 30, he has given 0.87 Fi. Fi is 415. You will get it is 13346.67 mm square. Okay, so the answer is D for question number 9. Clear? Next question. So that is for a balanced section. In this problem, the concept is both compressive force and tensile force will be equal. So last question for the assignment. So in this, the required tensile reinforcement for factor design moment is equal to 850 kilonewton. Considering, so we need to calculate overall depth. So you can see here, AST required, we need to calculate. So effective depth 940 as already calculated, and lever arm you will have separate formula. Lever arm Z is equal to JD. So that Z is equal to 0.5 plus 0.25 minus 1.11 mu divided by FCK BD square. These are very long derivations. These are all not required in your exam. So just focus on the concept. So if you will substitute the values 0.5 plus 0.25 minus 1.11 into 830 into 10 power 6 divided by 30 into B is 1000, D is 940 square. So I will get into 940. So it will be Z is equal to 906.1077 mm. Okay, this is lever arm. And if if you will calculate mu 0.87 FIAST into Z. So mu is, he has given 830 kilonewton meter into 10 power 6. 0.87, Fi as 415, and AST is, he has we need to calculate that AST, and Z value we calculated as 906.1077. So AST you will get, it is AST 2537.0610 mm square. Clear? So option D for question number 10. So this is the end of reinforced concrete road bridges. So if you observe, the repeated problems you will get, because it is a design. We need to calculate moment capacity or load capacity, like that. Okay. So no new different varieties of problems are not there here. Clear? Thank you.